Welcome to this week's Lunch and Learn session on Graph meets Kubernetes, where we will discuss how to deploy and manage an ArangoDB cluster on top of Kubernetes. So what is ArangoDB? Just in case you never heard about ArangoDB, so ArangoDB is a scalable graph database, which in addition supports other data models. So at the core, we are centered around a scalable graph model. Then we also support document, key value, and obviously graph. On top of that, we have what I would refer to as advanced query capabilities. So for example, our full text search and retrieval engine, Arango Search, our iterative graph processing framework based on Google open source framework Tragel, and then our GraphML and analytics stack, ArangoML. And then most important for this talk, all of this wouldn't help if you couldn't easily deploy it. This is why we early on set out to develop our Kube-Arango integration, which makes it really easy to deploy ArangoDB on top of Kubernetes. We will also, even our own managed service Oasis is relying on this, which makes it easy for them to target different cloud providers to different regions and basically just set it up in new environments. So ArangoDB, how does it look internally? We don't have to go into too much detail, but just to give you a short overview. So we have three different kind of node types. So first of all, there's the coordinator, which is in charge of receiving queries and then distributing it throughout the cluster. Then we have the DB service, which are holding the actual data and doing the low-level query processing. Last but not least, there's the agency. It's kind of the distributed brain of the cluster, making sure we're keeping quorum and also storing vital information, which can be retrieved from DB service or coordinators. So on the other hand, what is this container orchestration about? So about 10 years ago, there was this rise in containers, and we're not talking about the physical containers we can see here, but basically little lightweight VMs. I typically don't like that comparison, but I think for this talk, it's actually okay. And this makes it really easy to deploy in the beginning stateless applications on top of large clusters. Since then, there has been a rise in orchestration tools for such containers, as for example, Docker. So what does a container orchestration system needs to do? First of all, it needs to take care of scheduling. On which node in a cluster should a container actually be deployed? And what happens if that node fails? What happens if that container fails? It needs to be restarted. Next but not least, it needs to take care of resource management. So basically making sure that each container gets the right amount of resources and isn't put on a too small node, or in this case, a too small boat here. Last, but probably even one of the most important capabilities is service management. One container by itself, as it's also the case for in an ArangoDB cluster, doesn't do too much. So typically we need to coordinate and connect multiple containers into like a bigger service. And this is what container orchestration systems allow us to do by networking options, by discovery options, where certain containers running in the network, and pretty elaborate techniques. By 2020, 2021, the kind of default container orchestration system is probably Kubernetes. And most of you have probably heard about it. Originally been developed by Google, but now is owned and maintained by a large number of different corporations as part of the Cloud Native Foundation. If we look at the internals of a Kubernetes cluster, it's similar to ArangoDB. There are three kinds of nodes. First of all, there's again a distributed brain. Here it's called etcd. This is here on top. Then we have some master nodes, which are receiving queries and distributing them. And then last but not least, we got the worker nodes doing the actual running of the pods. Now, obviously, it's a challenge. How can we combine that? So how can we run one or multiple ArangoDB clusters on top of Kubernetes? And keep in mind, it's not the only challenge to deploy a cluster, but you want to keep it running over time. So scaling, upgrading, recover from errors, etc., etc. And especially if we talk about persistent services, so service or systems holding some state, as a database obviously does, this becomes a bit harder. Keep in mind that the original Kubernetes has been developed for stateless services. So that would mean if a container fails, you can simply restart it. But if we are talking about database containers, you don't simply want to restart it, or you don't simply want to shut down containers because you don't know whether you might lose any data or availability. Luckily, their Kubernetes has developed quite a bit into the area and direction of persistent services. And one very powerful pattern here is the operator pattern. So operator pattern, it basically encodes a lot of the operations an operator or admin would do into code, and hence makes it easily accessible from the even kubectl, so kind of like the one of the default ways to access and control your Kubernetes cluster. So for example, installing ArangoDB can be done by a simple kubectl apply, simple cluster.yaml, or how you define your YAML. Furthermore, it comes with a so-called CRD, so a custom resource definition, which introduces a new type of resource. So it's then fully supported by kubectl as well. Again, this is a tool we saw earlier, which allows you to access your cluster. And then we can do something like kubectl create my custom resource, kubectl get my custom resource, and ArangoDB obviously comes with its own CRD. So we have different, even different CRDs, but one of them is, for example, the ArangoDB deployment. And then you can just get all the different deployments from your Kubernetes cluster by kubectl get Arango deployment. And this makes it really nice to interact with ArangoDB and to also interact with different systems, because it just becomes part of that normal tool chain. So what else does Kube-Arango, our operator, do? It's exposing the ArangoDB as a service. So first of all, as mentioned, this is a part of service management we should talk about. First of all, it's about internal discovery. So within that same cluster, we have the different nodes, the different containers of an ArangoDB cluster, which needs to figure out, oh, where is my coordinator running? Where's the agency running? Where's the DB server running? And this is exposed through cluster IP and internal DNS, and the traffic is shared between instances. The second part is that in most cases, we want to expose the Kubernetes service outside of the cluster, outside of the Kubernetes cluster, and make it available for people. And so especially if we're on a cloud, so for example, GKE, or Azure Container Services, then we expose the coordinator endpoints via a load balancer. Typically, those are provided by the cloud vendors, cloud providers. But if you're running Kubernetes yourself, you can also expose it through your own load balancer. And this allows for external access to the cluster through those load balancers. And this will then also enable traffic balancing via the load balancers. Obviously, you can also just expose the coordinator endpoints manually, but recommended practice is to have those load balancers up front, because they give you a single endpoint and then make balancing traffic between different coordinators much, much easier. So deployment configuration. So as said, we can also configure different deployment types. So for example, your TLS settings for enterprise, the production settings. So this is anti-affinity. What this refers to is if we are running on a Kubernetes cluster, we obviously don't want that all our DB servers are ending up on the same virtual or physical node underneath, simply because if that node would go down, this would take away all our data. Similarly, with the coordinators, we don't want all coordinators ending up on the same node. So what can we do? We can configure them, and the operator will do that if you switch to production mode with anti-affinity rules, which basically say we only want one instance of a DB server, one instance of a coordinator on a single node, and the next one should be anti-affinity on a different node. We can also define in our deployment YAML our resource quota configuration, CPU, memory, storage, etc. Define liveness and readiness probes for the deployment, and then also further Kubernetes service configurations, which we saw on the previous slide. Storage. Kube-Arango can work with two kinds of storage. One is the local storage, or here bare metal, and this is then typically co-located on the same physical or virtual machine, but that makes a pod or that container be bound to a specific node. So meaning if that node goes down, we can't easily restart it somewhere else, and also volumes need to be resized manually. If we are running on a Kubernetes cluster, we often have so-called external storage available. This can either be storage by a cloud provider, like an EBS volume or something similar, and then it can also be software-defined storage solution running on your own cluster. But as this storage is not tied to a particular node, Kube-Arango can actually restart a pod. So for example, a DB server on a different node, and reattach that volume to the same volume where all the data is already at, to that newly started pod. So also it then supports the resize options of most cloud providers, as they offer or also software-defined solutions, as they offer an interface where you can say, I want to scale that volume up or down. So how can we scale our cluster? So we have started, and now we figure out, oh, we need more nodes. Scaling up is pretty easy. We change our config YAML, or we can also do kubectl scale. And in that case, when we are scaling up, a new pod is created. That pod or that instance, for example, DB server or coordinator, will register in the ArangoDB cluster, and as the operator will just wait until that new pod, that new instance is marked as healthy, and then continue with its operations. Scaling down is a bit harder, as with most persistent services, persistent systems, because we need to make sure that we are not violating any guarantees we have of the data. So for example, if we're saying we want a replication factor of 3, so our data should always be on 3 different machines in the cluster, we don't want to destroy that that guarantee. So how are we scaling down? First of all, we are moving the operator. So not we manually, the operator will move the shards to different DB servers. And this is done then with honor of replication factor. So we'll move shards until we have the desired replication factor. The server will wait until all operations are finished, and then the server, that instance, can be shut down and removed from the cluster. So basically, the operator will ensure that even scaling down is a safe operation. Monitoring, another really important part of any production system, and Kube-Arango makes it really easy to expose all underlying database metrics. So we can see here in our spec, which we would use to deploy a cluster, we can simply define annotations for Prometheus Grafana setup, and then it will automatically expose that and set up or push it to Prometheus Grafana stack. Also, ArangoDB comes with a number of default dashboards for different personas, which makes it really easy, as there are tons of metrics. But if you go to one of those default dashboards, so for example, there are ones for database users, there are ones for sysadmins. They basically come pre-configured with the most important metrics for that persona, making it really easy to, at least get started and then maybe refine your Grafana dashboard even further. Thank you so much for listening. If you want to learn more, first of all, there's learning about ArangoDB. We have a large number of interactive tutorials if you just go to our learning portal here. Then the operator, same as ArangoDB, it's open source. So just go to GitHub, check it out, or it's also in our documentation. And then last but not least, our managed cloud service Oasis, which is also built on top of the Kubernetes operator, is available via cloud.arangodb.com, and it's a really easy way to get started. There's a free trial, so you don't even have to manage anything yourself. Thank you very much for listening, and until the next Lunch and Learn session.